Thank you, Dan. That was a kind introduction. Hello, everyone. Like Dan mentioned, my name is Shivakumar. It's a long name, short go by Shiva. So thank you for invitation. Great facility. I had a lot of opportunities to visit Samsung, but never had this kind of a forum to discuss and share my experiences. Thank you for that. So about myself, I know, like mentioned, I'm the co-founder and CTO of Due Mobility, and I'm an electrical engineer. Have been practicing, on the hardware design, Internet of Things, now big data and machine learning and artificial intelligence. And my specialization subject teaching is IoT for Santa Clara University and Sonoma State. It is a part of their master curriculum. Now they were trying to include it on the bachelor's curriculum. So today, what I'll do is that I have, divided my presentation into three parts. One is more about what the smart city itself, what the trend happening, what's the requirement. In fact, just before this coming here lunch, Stefan, Dan, and Eric, they asked me what are those drivers, Probably I'm going to cover up a few pointers. What are those drivers? How the smart city has been, evolving. That's one part. And second part is I'll be covering up on the smart city use case itself. No, let me correct. Before that, I'll talk about the standards. In fact, the topic should have been standards and the smart city use cases. So I just reconfigure my presentations. So I will cover up on the standards. What are the standards available for smart city globally, more so on the North America market. And the third part is more of use cases, what I have been practicing it. I'm going to share some of the model which we have implemented for three cities. I'm going to share today those use cases. And in the end, I will also share what is happening overall in the market and what are the trend in the technology, how the smart cities are happening and what the citizens as well as community is expecting from all this initiative. So yeah, as you can see, what are the driving force? Yes, the speed and availability of technology has been increasing a lot. Gone are those days, almost a mobile device or you take any handheld devices, it's actually 4 or 5 times than the supercomputer what we used to have in early 90s, right? It is becoming so powerful and energy efficient and a lot of applications loaded onto that. So you don't have to, the citizen don't have to carry any of their desktop or their laptop, they just carry their device. The speed is increasing, the efficiency has been increasing, and the technology has been there. And for last 2 years or 3 years, even the connection also has been increasing, right? We had 3G, 4G, now 5G, even the private networking is coming up. I'm going to talk about a little bit on LoRa, Sigfox, how the mesh technology is happening. It's increasing terribly lot of things for last couple of years. And the other popular statistics I take is that as per the United Nations Commerce section, they say 60% of the world population is projected to move to the urban cities. Gone are those days. They are in the rural. They are moving into the urban. Where when people are moving to the urban, then we need to have the lot of these initiatives. The smart cities are gearing up towards that. And smart city definitely will be engine for the global economic growth. It's a slow pace. Again, it's a little bit of counteracting my lunch discussion, but it is happening. But it is not that pace what we all want, I mean, any enterprise or any companies, they would like to have a very pace improvement, but that is not happening, because cities are learning. It will take its own pace to catch up, but it is catching up. Every year I see the trend is happening. And then another statistics is by 2025, 600 cities in the world will generate 65% of the world economic growth. This is again from United Nations. If you need more details, there are more references, statistics available on that. What are the challenges? Yes, those are the trend. Now, what are the challenges and opportunities? When I say challenges, obviously the opportunities also has come. So we have pollution control. It's, most of the cities have this problem, this, aspects. Now, how do you have a technology based to message and get the pollution control driven? Transportation, all most of these, applications are hooked up to the local transportations or the local transit systems, as well as the agency transportation. Utility, all your energy efficient and grid systems, it is becoming a technology oriented there. So you have a lot of challenges as well as opportunity to integrate those utility equipment. Agriculture, especially on the rural side, a lot of technologies are getting involved to get these agriculture crops to get into the mainstream. And improved health, all the local hospitals, municipal hospitals are getting integrated to get into this IoT angle. Resource management, this is more towards for the city planning or the county planning. That's happening at a smaller section, not like earlier verticals. And then, of course, public safety is a big push there. It could be your, it could be your waste management, or it could be your flood monitoring, or it could be evacuation of any emergency. So those things are happening in a messaging system. I'm going to share a couple of examples about on the public safety applications. All right, the smart city vision, it's again a bigger point of it. I'm sharing some of the materials which I have been working and have been researching with the NIST, which is basically Global City Team Challenge. I'm going to come in a bit about that. So you have the goal is to achieving social justice, sustainable economies, and environmental sustainability. So when you want to achieve this major core goal, obviously you need to have some technology connected to those aspects that. And then we have the informed choices and decisions, because citizens are becoming more and more intelligent and they have more empowered with a lot of devices. Now we need to equip with them, more information and more choices. Gone are those days, okay, you have only one choice, you have to come to, planning department every day or every week to get your permissions. Gone are those days. Citizens or residents are expecting that it has to be, on my mobile phone. It has to be on my devices, and I don't have to come every time. They are demanding, that's happening in a global trend. And design of smart city, gone are those days, there's only not just the sensors. Sensors embedded. For me, coming from an electrical engineering background, this IoT is not a new, it's actually, it has been there for last 2.5, 3 decades, right? We have been doing the embedded electronics. So that, let me pause here and take some kind of a statistics from here. How many are from the engineering or R&D background from here? Oh, all right, quite a good. How many are from business development, marketing? Yes. Okay, good. So we have a good mix of audience here. I'm assuming a similar audience on the web. So because I'm going to explain a little bit on the engineering side and on the business side, bear with me. I had to go through some of the steps involved in that. So then design of smart city. So we have all these verticals here. So as you can see here, we have smart manufacturing. Any manufacturing they want to integrate with the smart city connectivity or a smart city initiative. And we have the open data. If you see, I'm sure, I understand that next week we have some chief guest from the San Jose city. So any government agency, if you see, they have the open data. The data has to be open to the citizen, and then they can integrate with their devices and see what is happening. Of course, security is another important parameter, which I'm not going to touch upon this because it's a very big subject. But there's definitely a vertical line. Security goes into all the layers or all the platforms over there. And then we have the smart health, smart grid. We talked about it. So now, what are the components? Coming from an, again, electrical engineering background, I would love to put the block diagrams. I love to put the circuits. Bear with me. So because I'll be going a little bit 1 or 2 slides on the technology side. So you have the devices and sensor. Then we have the MCU, then city connectivity. It used to be connected with the public connectivity. Now, some of the cities, what a trend I've seen there, they have their own connectivity, you name it mesh networking or a LoRa networking or a Sigfox, they have their own networking coming to the MCU. And then city cloud, So it used to be an open source cloud or go for an enterprise cloud. Now, few cities, their offering is that they will have their own cloud. And then, of course, application, that is open to the public or open to the citizens. And anybody can develop their applications and access it from the cloud. Of course, they go through all the credentials, whether it's relevant or not. So these are the basic building block for any smart city. I'm going to share one schematic also how we have done and what are the stages involved to develop the the smart city application. Okay, that was more about the setting the foundations, what the smart city and how we can, what are the trend happening, market trends. Now let's see the protocols and standards. So this is a protocol which I have been following it up. There are at least 8 to 10 protocols are there, in the smart city. We really look into the worldwide, Europe has standards, then Asia has standards, US has got 3-4 standards. But what I am using here is an Open Mobile Alliance, which is a lightweight machine-to-machine standards, where we have sensor connected to the microcontroller unit, and then we have IPSO. Basically, that's then another standards, which basically it's an open standard where they have the data models. They have created some data models. Any developer or any researcher or any enterprise, and if they want to develop any product, they can utilize those data models and validate their design. It could be a sensor level or it could be at the hardware level. They can validate those aspects there. So then we have the IPv4 and IPv6. As you know that most of the connections are on IPv6. IPv4 was not sufficient to address so many devices, what we have been talking. Now the new one is then IPv6, which can, address several billions of devices over there. And 6LoWPAN, which is coming, for your mesh networking. All the cities have got the 6LoWPAN connections. They have their own mesh and connecting through the 6LoWPAN. And then we have, the APIs, which is from the Open Mobile Alliances. So in this context, I just want to mention that, we are utilizing some of the open source hardware, and also we are using some closed hardware. For example, in 2 of the projects, where Dan and Wei, they helped us in some of the senior projects where we're using the Arctic platform to build some of the prototypes there. It's under development. We just want to validate not only for the open source, how it actually react or how it respond to some of this commercial hardware. I'm going to share some examples at the end. Okay, now that was about the city and about what the driving force. Now, this is where I am involved. I'm the team lead for 3 cities. This is hosted by National Institute of Standards and Technology, NIST. So it's under the Department of Commerce. Many of you know that NIST, actually they are a standard body where they put all the standards, test specifications. Any application you want to go through that, you have to go through their framework. So this is supported by recently by US Department of Homeland Security, Science and Technology, and the National Science Foundations, International Trade Administration, National Telecommunication and Information Admin. The goal here is that integrate the enterprise, city, and the research scholar. They put an action cluster. They call it an action cluster. So they provide some kind. They develop some kind of a product to that. So this one they started in 2016. I'm part of that consortium from then, and try to develop some prototypes for the few cities. Okay, what is the goal of GSTTC? It's a 4-5 line paragraph, but I will read out to the benefit of here and on the web. It's to establish and demonstrate replicable, scalable, and sustainable models for incubation and deployment of interoperable, secure, standard-based solution using advanced technologies such as Internet of Things and cyber physical systems, and demonstrate their measurable benefits in cities and communities. So if you really look into this definition, they have three parts. One is the replicable and the scalable. There has to be, NIST say that just not the prototypes, so it has to be scalable. Someone has to they don't have to reinvent that particular applications. So you need to scale it up. And then sustainability, it has to sustain. It's not that every 2 years, they change the technologies or they change the, parameters to that, and it has to be sustained. And another important thing which the Department of Homeland Security involved for last year is the security. So now they made it a point that without going through that framework, particular framework, it's work in progress again. Actually, they're not shipping any product, and it has to go through those security layer from the DHS parameters. And then measurable. So what is that? It's just not, providing the prototypes or putting it there. Every 3 years or we have a short-term goal. What is that you achieved from these prototypes? Mid-term goal, what you achieved? And long-term goal, how much is the beneficial for the user or for the citizens? So they have a measurable goals. We call it as an action cluster forms. So every year we have to report to them, okay, this is what we have measured, this is what we have targeted, this is what we have measured, and this is what is the next 1 year. So we put all those add stick into that, and it is reviewed by NIST. There's a review committee, they review it, and we go there and present. Every twice in a year they have a conference like this. One will be in Washington, D.C. predominantly because that will facilitate all the federal government to attend that. So everybody will be attending there, including sometimes from secretary level. So they'll go through these presentations on that. And these are the different standards. Again, it keep going because one of my topic is on standards. So you have OMA, you have OSIS, Open Interconnect, Zigbee Alliance, IoTA. So currently we are practicing, at least I am practicing, is more on Open Mobile Alliance and the NIST standards, because there are so many standards are there and we have limited bandwidth, right? We cannot be going everything. But we are practicing two aspects to that and demonstrating those products into the GCTC clusters. Okay, now this is about the GCTC, rather the NIST framework. So their goal is to a reference framework for the development of architectures for incremental and scalable smart cities. So they have got multiple team from universities, cities, and the companies. So they form a group where each group will meet every month through conference and provide this specification, this work in progress. And there are about 6-7 different specification framework they are putting it, and they discuss. And every 6 months we come out with the one version of the framework, and we try to implement that. So far it is not officially made anything, but we try to implement those framework on that. So if you need more information, you have a lot of details. I can also share some of the framework what NIST is promoting, so we can probably correlate with your product development there. Okay, now like I said, they NIST name it as an action cluster, GCTC action cluster, which consists of municipal government participant that will deploy the smart city, and technology provider. It could be any technology provider like Samsung itself, IBM, AWS. Then you have Cisco, Intel. Those who are all providing the technologies, they can be part of this action cluster. And the third element is team from university. It could be a research scholar, or it could be a faculty, or anybody who is into IoT space. He has to be part of it, and they call it as an action cluster. So their job is to study the city requirement, go to the city, study the requirement, come back, and in first phase they put the specification. Second phase they go and put the prototypes, and third phase is the productions. Their job is to only go up to the prototypes, and then they hand it over to the city, and city will look for an outside funding or some vendor who can support their long-term goals. So their job is to get up to the prototypes. Now, what are the superclusters? Actually, they have named is 7 action cluster. Each one has got its own team, headed by an industry or some private entity or from the NIST. Oh yeah, NIST will be there, one of the member in all these action clusters. So they have a different action clusters, which is, they have deal with that particular subject, public safety, transportation, energy, water, public Wi-Fi broadband, education, and building. So myself and two other faculty, we are involved in the education. The education super cluster is job is to that NIST say that, okay, now out of these 100 cities, these are the cities, you need to, go and train them. So we're identifying some cities, train them from the starting, from what the technology involved in that, what are the facilities available, what kind of prototypes available. So I'm going to share that syllabus also, what exactly the education cluster is doing with all the cities. Okay, so that's about the an overview of standards. If you're interested to learn more about this NIST framework, feel free to contact me. I have my contacts at the end of the slides. I will share those links so that you have got all the standards. Be prepared, they're all work in progress standards. They have 60, 70 pages of documentation, so you have to be prepared to go through that. But they're all in progress. Hopefully in few months of time, you will see those in implementation in the field. So I have taken, for the best interest of the time, I have taken two smart city examples and one on the education cluster, what the education cluster does about it. So before that, I know, in this, most of you have gone through this step, but I just put my thoughts, what exactly involved for you to build a smart city, or for any developer who wants interested in that. So first we talk about the concept paper, and then we actually, concept paper is nothing but, you put your thoughts, that's what when I do this capstone or a senior design project at the university, when I mentor them, I ask them that, forget about the technologies, forget about what technology is available. Just put your thoughts on a paper without having your laptop or devices in front of you. Just put your thoughts. So we call it the proof of the concept paper. They write the concept, what concept they want to do. It could be waste management, or it could be smart campus, or it could be smart light control. Whatever thoughts they have, we ask them to put that, and ask them to put the block diagram. Okay, go one level below the concept paper. Put the block diagram. What are the blocks involved in that? You remember in the second or third slide, I talk about the building blocks. What are the blocks involved in that? Put that block. And then go on to the schematic, put all these block diagram into schematic, we don't have to go into the schematic because, we have everything now available, right? We've got a modular model, right? You take one hardware model. Most of these experiments we have done on open source hardware like Raspberry Pi or an Arduino board. We are also implementing some commercial boards. Like I said, we have the Arctic Bottom also to be part of the whole concept here. So put those schematic there, put the hardware board. What is the connectivity, So you also need to see the connectivity, right? If you are deploying waste management in a, say, downtown, some city may have the Wi-Fi, some city may not have the Wi-Fi, or some city may have, may be interested, okay, now we have a, LTE connections, just go through this LTE, I remember one in city of San Leandro when we did it, they said we are good at LTE, we got some kind of an, arrangements with one of the carrier, so we please implement the LTE. And some people say that, no, we have a mesh networking, you don't have to connect anything. As long as it comes to my mesh, I will take care of transmitting it to the mesh, So that's the thing you have to see, that what kind of connection you get. And some applications may not require Wi-Fi or your, LTE. You might require Bluetooth. Some of the applications you don't have to send it to the public. You just do it to the Bluetooth. For example, health applications, right? You have devices or you have wearables, Everything you can connect to the Bluetooth and then connect it to your device, and device can take care of communicating further to the cloud or to the agency what you're looking for. You have to look for that. And bill of materials, I just put as an industrial term there. You have to put all your components there, what components you are going to use it, modular wise or component level wise, and the software, hardware, firmware, what components you're going to use it, please list it. And then they build the prototypes, put everything there, like you have the assembling the sensor, then you have the writing the device driver software and APIs. You need to write the APIs because though it says all the cloud provider, they say, no, it is a very easy integration, you can integrate, but I don't agree there because we have to go through their logistics, their facilities, their kind of an agency, what they have, we need to go through that. Somebody has to really spend some time on writing the APIs to your hardware. And then you have the client integration. Of course, you have to integrate with the client. And then you have the field testing. Before you really make it 3 to 6 month testing. And then we have the beta version and production. And the last one is very important, I tell my students, is documentations, right? We are all good engineers, we are good at putting everything, but we don't document it. Because if you don't have those documentation, it will be very hard for us, right? Who has written, what kind of software we have, what kind of hardware is used, what kind of bill of material. Because goal is we have to pass it on to someone, next students who can take care of the next level of development. So we make sure that, put all the documentation there. So this is again, I put based on my experience. It could be changed based on your industry experience. Okay, this is the one example, my first example, City of Rohnert Park. So basically, City of Rohnert Park, we discussed with them in the first meeting. They said that, okay, now we have the, lot of floods in the mountains and lot of floods in the city. We need to have some kind of devices where, you get a messaging, that, okay, there is a flood happening now. Then I need to be able to, inform to the citizen or residents of that city, and they can, take corrective actions on that. So we actually discussed and we sat down with the team and we came out with a very simple model. It's not a rocket science. It's a very, very simple science project. And then now we're trying to convert them into a real full-blown production unit. So we had a rain gauge sensor. We put a simple analog rain gauge sensor. It measures the rain, what is the amount of rain or what is the amount of water it get it. And then during that process, city also said that, hey, if you are putting electronics, everything, why don't you put some temperature and humidity, because already electronics is there. Then, yeah, why not we put, because we have got multiple GPIO port. I can interface 20 plus devices to that. Only I need to program it a little bit, right? How I can get those GPIOs ported and program into that. So then they said put the temperature and humidity and the wind speed also. They want to include that. We identified those sensors. Temperature and humidity was very easy because that has been evolved for long. That was easy. Wind speed, it took some time, but we identified that vendor. These are all the off-the-shelf component. We never went for any production or anything. And then we have the A to D converter, take that analog input to the digital conversion, simple A to D converter uses from National Semiconductor. And then we have the IoT hardware platform. So here we use the ARM embed processor. And then have this embedded C. I mean, some students are good at the embedded C. They developed embedded C. Some are good at Python, say they can do it in the Python. So that option we're given. And then the connecting gateway. We started with, they have a very good system in I don't know if you've been there in the Sonoma County. Those of you don't know, it's about 1 hour drive in the north. If I say Sonoma, they may not remember, but if I say it's closer to the Napa Valley, everyone, yes, oh yeah, where it is, they remember. So it's actually 1 hour drive from San Francisco. And there, we have electrical science department. So there we have this senior design project. And then we have the connecting gateway. We tried with they have their own satellite, from mountains to the university, they have their own satellite. Somebody has, thanks to the company who donated. So because there's no Wi-Fi, there is no Bluetooth, there's no 3 GSM, but there is a satellite, so they can transport that data to the satellite, and satellite will come to the SSU center. From center, we give it to the data to the city, then city can decide what they will do. Our job is to supply the data to the city, city will decide whether to give it to citizen, no, you will control it or will turn it. So then recently we experienced that LoRa is also coming up. We said, why don't we add in LoRa devices to that? We are experimenting, still we don't have the result, but we should have a result in next 2 to 3 months, because we want to put the LoRa devices across the places, and then collect that reading then. Then we have the IoT cloud platform. We started with, when it was AWS was very popular. In fact, our first experiment was there was no cloud at all, right? 4 years or 5 years back, if you see, there was no IoT components at all, APIs, You had to have that MPTT broker or some broker you can connect the devices. So we did develop our server at someone's garage, so it was there, and put all the sensor data to that garage, and then try to manipulate from that, and then get the data and do the analytics out of it. But after that, we realized that there are some companies already there, so AWS and then of course we developed the mobile applications and the desktop Mac or Linux. So this is the second level of the block diagram, where you can see here, the so here we have the water gas sensor, and then it goes to the internet, of course, through an hardware, and then Sonoma State is the campus, where it controls, and then it gives to the SSU LAN network, and then we have shown it user, but business logic is that it goes to the city, and city will distribute the messaging the data, because and these are the some data we have shown here: temperature, humidity, and rain temperature. What is the rain gauge there? So we have measured it in a simulated way in the sense, because when we developed this about I think 3 years back, that next year we wanted to try it out, and we went into drought, right? There was no rain at all in that, So then someone said that, yeah, you solved a problem, But this last year, we had a lot of rains. We put it into the field, and we got some data to that, So we now we're putting into the production model that. So this is a screenshot or the framework on the flood alert messaging. But you can add many things. Like I said, device is becoming so intelligent. You can put all the data here. So we have the flood alert, which is a push notification. Whenever there is a flood, you get a flood notification there. And then we have the items to carry, because whenever there is a flood, what items they have to carry, So we put all the items. City can decide that these are the items you need to carry. We are supplying it, or it could be a sandbag, or it could be, your food items, whatever items you want to do it, they'll put those items you that. And you can share also that, sometimes if you're in emergency, you can share those applications and all. So we can, put all whatever sort of information you want onto this application. The goal here is to get all the live data and then, display it onto the phone or onto the device. So this is some experimental which we have done at Sonoma State. As you can see, one of the student and Professor Farid, he's there testing in the lab. So this is the second set of sensors, So what we have done is, as you can see, the student holding the pipe, where what we have done is we put the proximity sensor in the top here, Hopefully this should work here. So on this pipe, what we did is we put a proximity sensor there. We inserted that pipe into the river closer to the Sonoma State University, and then whenever water flows to that level, it could be, you can decide at 6 feet or 8 feet or 10 feet, So then the proximity sensors is on the top here, and then it actually senses that there is a water level triggered, and then it sends the messaging through 3 GSM or 4 GSM. They have got a Wi-Fi, they've got a LTE model into that, and they send that messaging. This is the second set of what you call the flood messaging. That was the first was in the mountains, where it was communication was through the satellite. This is second one is through, they're using the LTE connection there. Okay, my second application is the city of San Leandro. This is again a part of GCTC action cluster activity. So this one is the waste management. We discussed with the city. The first thing when we go to the city, we'll ask them that, okay, what are your problems? What are the problem areas? How we can help you, without any connecting to any of your commercial thing. We are here as a research bodies for the NIST, and what are your problems? Then they said, okay, we have one of the problem is the waste management, right? So they have outsourced their waste management to a company where they invoice them every 15 days that, okay, every day I went there. This I'm talking about the waste management controlled by the city in the downtown, They say that they send me the invoice that every day they went. Instead of that, can we, control that? Okay, we tell them that when they have to go, as an outsourcing company, that, okay, you go in once in a day or twice in it, once in 2 days. So they get this messaging and they send people for, we call them as a trash collector, then they inform them. So here a simple concept again, we have the proximity sensor, and proximity sensor, it senses the level of the trash, and then it trigger through an SMS message that, okay, now trash is full, So what we achieve from here is definitely cost reduction and labor reductions and the route flexibility. So we also connected this one to the Google Maps, so that whoever is going, the trash collector going to collect the trash, he can also go follow that Google map and go as per the instruction provided them. He'll have a handy map to that. And this is a system block diagram where we have the ARM Cortex M3 processor, which has got that time it used to be 3 GSM. Now I'm looking for a 4G card there. So 3 GSM, which is manufactured by U-Block. So they have cellular modem and GPS server. And for the text, we have integrated with the Twilio software, so that Twilio server. So they help us to send the text messages, So this is work in progress. Now prototypes are available. We would like to hand it over to the city or any other city for that matter who are under GCTC, and then they take it from there for the production version. This is the, again, two types of trash bins we have. One, you can see the sensor, put it on the top of your waste bin, and another one is more of a park, when you go to the park. So you will see those sensors installed in that. Two of the students helping me to install those sensor and wrote the driver software there. This one, left one is from the San Leandro, and right one is a picture taken from city of Cal Poly, San Luis Obispo. So we did the first project prototype was done there. Then we convert them into San Leandro city there. All right, so this is, the next level what we are working on that. It is actually, we call it as the IoT development platform architecture. So the goal here is that put all the permutation and combination into that box. So any developer or any startup, they can utilize this platform, So what it is, it means that you don't have to just depend on the Raspberry Pi board or any open source. Let's put everything here what is possible in this box. All are evaluation board. Again, these are all not a production. You know how it goes, right? Evaluation board to the production. There is different process if you're going for a volume business. So the goal is that we put all these 9 verticals here, and it has got the environment monitoring, smart agriculture, smart city, smart water systems. We identified the sensor for the water, it can measure your pH 4 and other water related qualities, So we have spent some time to identify all the analog sensors. Now they are all converting into digital, some of them are digital. And then the manufacturing. So here we want to make one general purpose PCB where all the hardwares are there, For example, in fact, one of the initiatives we are taking with is the Samsung Arctic. We put that Arctic platform, Marvel platform, Intel. Intel is more of again a research platform, and then the Snapdragon from Qualcomm. So we'll put all those boards. So anybody wants to develop anything, for example, some vendor, they offer the video applications, right? So we need to really have a lot of video applications to that. So we put everything there and put one cloud platform and put all these MQTT, CoAP, IPSO, and 6LoWPAN connections to that. And then, of course, on the application layer, we have mobile, tablet, web, smartwatch. Smart glass, we tried it. It's slowing down on this thing, but we'll at least have web. And recently we used this, S3, Gear S3 for one of the applications. It's already coming out there. So we should be releasing that, connecting to this platform there. So these are the kind of an hardware platforms we have built. So it's about 9 to 10 boxes which we have built for different verticals on that. So each boxes will have a lot of research going on that. So anybody wants to have those, you remember that we talk about these verticals. So that we converted them into a box level here and put all those. Again, currently it's all working in open source. So what is happening is whenever city asks some requirement, what we do is that we just take this box and then take their input data, integrate it, and then write software for the API for the cloud, whatever the cloud they have. And one thing trend happening is most of the cities, they actually want to work with their own cloud, because they're all legacy systems, So one thing, as an enterprise, as an, from Samsung point of view, what I would say is that whenever you're having any cloud, there has to be some connections or some broker which can connect to the city server, because they don't want to really change anything. Just for a couple of sensors, they don't, no, we don't want to check, take any risk on that, So that's one input which I learned from the city. They said, I have this legacy server, you need to connect to my server so that everything is controlled by that server. They're not really prepared to change their connection, which I also agree with them, because it has been going in for last several years. So they would like to implement that. Okay, and this is about the education cluster. So education cluster consists of a faculty, Dr. Farid Faramand in Sonoma, who is the chair of electrical science. He, me, and my another professor from Santa Clara, we form an education cluster. So job is to reach out to all the stakeholders. So we are taken in a phased way, 2 or 3 models there, and you utilize the best practices. What are the best practices? We teach them what are the best practices utilized at, how a smart city works, how an IoT works. So we have a curriculum for that. It's a 2-day curriculum. So we start in the first day about invite all the stakeholders at one place and talk about this process there. And prepare education workshop for the stakeholders and share the material, establish and education platform. So basically we prepare the education based on their requirement. Yeah. Then what are the most critical problems for the smart solutions? We talk about that, and share some of the learning experience from the earlier one. And remember the GCTC consists of 100 cities, right? So we learned a lot from these 2 conferences. We learned each one will go there and present. It's a extensive presentation. So from morning 8 to evening 6 o'clock, everyone will be presenting. So we learn from that and get back to the city, what city we are working on that. Critical problems and share information about appropriate technologies, what is available, and address of course, there are some funding opportunities from National Science Foundation or from the private investors. We'll, try to invite them also to be part of those speakers. They can explain their, roadmap and create networking opportunity between the stakeholders. Goal is to bridge the cities, enterprise, and investors, and then update NIST, that we are doing this, and then they will take further directions for that. All right, so that is about what is, what we have been doing it. I shared with what the use cases. Now, what is my experience, I'm going to share that. Now, more and more, the applications or your processing, they would like to have an edge computing. Edge computing is coming up, because gone are those days, okay, I'll send the information to the cloud and wait for that information. So a lot of things, these applications are happening. So edge computing is, one important parameter is happening. And the narrowband connectivity, NB IoT is, is on its way. It's actually some of them federal thing, they're working with the federal here. In Europe already there for this narrowband technologies in terms of your LoRa and the Sigfox, it's coming up. Because that's a very easy, those are a classic example, very good example for the smart city, right? I mean, you don't have to connect all the devices. And all these devices, remember, they're all 2 or 3 wires or 4 wires maximum, right? You don't need a elephant size of processing there. You just process it and then make all the calculation in the local and send it there. So that is happening, narrowband. And then the wireless mesh networking, which is a part of narrowband IoT. And wearable devices, yes, there is things are happening. Now they say that, okay, at least on the messaging, when you see manufacturing, one of the applications I have done is manufacturing or transportations, like a train, One of the applications we have come across is Amtrak, for example. They said that, okay, now I have got so many technicians are there. They don't have to look into their mobile phone every time, right? They have the variables. Okay, now a technician, okay, go to such compartment, go to such maintenance, then they will go shift from other to the, just a notification. If anything beyond the notification, then they go to the devices. If anything beyond the devices, then they can go to the laptop and do that. So that is happening. It's go or no go kind of an thing. It's happening, and especially with the newer one, it's got the great LTE connections. So that I'm seeing the trend, and then the machine learning and AI implementation is happening. It's actually now we have so much of data. What we have to do with that data? Machine learning and then AI implementation is happening. People are building that engines. I've seen that a lot of companies, they are part of this action cluster. They say that we have this part and they're doing that. And what I see future trends is that, so we have all these sensor data input coming at, and then the cloud, it could be a private cloud or our own cloud or enterprise cloud. Cloud is already there. And we have the analytics. A lot of analytics is happening now. It's already there. Now, what do we do with that? So we had to go on to the next step is the machine learning. Take that analytics, do the machine learning. And what do you do with the machine learning? Do some kind of an artificial intelligence, right? It could be any application. Do that one. And output of artificial intelligence is a robotics, right? This again, next thing, right? You have to input to the robotics, then robotics can feed it back to the sensor. So it's actually circulating back to operate those of the devices there. So this is again my thoughts. I could be wrong, but I just put my experiences, what is happening. Currently we are here, data analytics. We are venturing into ourselves into machine learning. Take this data. We got a lot of data. If you really go to the city, open.go, there's a lot of data and it's open. You can take that data and build your machine learning and artificial intelligence. Cities are quite open to these days. They said, okay, I need some expert like you, and then please implement those aspects, and it's happening there. So with that, that was my last slide. This is the acknowledgement, which I would like to thank Dr. Farid for a month, who is a part of this whole aspects, and some of the national body, National Science Foundations. They're all part of this action clusters. If you really go into the specifications, you will see them contributing to that. When we have this smart city initiative, they're all part of the meetings. They come and contribute, and we're learning from them. Yeah.
Open to questions? We have one, and then you can pass it on.
You want to go first? Go ahead. All right. Thank you. Good presentation. And I wanted to know what you thought about trying to make it more economical for large cities. San Leandro, Rohnert Park, they're nice little cities. They probably have a technological bias and they're smart about this kind of stuff. But if you're talking about, the cities that are above 10 million in population or a very high population density, it seems like those are going to be the most beneficial, especially where people may not even have smartphones. So what do you think about how you would implement smart cities in that scenario?
Great question. Thank you. So yes, for bigger cities like 10 million plus our thing, yes, they have. Let me step back. Each city has got their own requirement. And if you go to San Leandro or Rohnert Park, there is a lot of difference. Because they say that we have a problem with the flood, and this city has got a problem of waste management. I talked about it. Yes, when you go to the bigger cities, they have a bigger opportunities and bigger problems to be solved. But my experience is that, I always go by step. Go to a smaller city and try to solve that one problem and then go on to the bigger city. In this global city team challenge, there are, like I said, multiple cities. They have got 10 million, the city what you expressed, there are this thing. So the opportunity there are definitely more than the smaller cities. But also you have to consider the time to development, because that will take some time. Because if you say San Jose, if you go and approach San Jose team, they might take some time to digest your request or digest your requirement compared to the smaller cities. Yes. But always I believe in going into a smaller city, smaller county, so that you can really work with them. It's very easy to access them and then go into the bigger cities. Hope that answers your question, sir. Okay.
You mentioned security briefly, but this seems like really, really important given, well, just a year ago, entire shipping network got taken down by a virus. So how are you doing security now so that you have to be both open, but, secure, right?
Yes, in terms of security, like I mentioned earlier, my initial thing, security, we have really not done a good job there. We have to do a lot of things on the security aspects, because security question is that where do you do that? Whether you do it on the device level or the connectivity, cloud level, or on the application level, People all across the thing we are doing. But one good thing happened is Department of Homeland Security, it was not part of the action cluster. Now they have involved it for last 1 year. Anything, any product you ship it, you have to go through that framework, which is under work in progress. Yes, we are lot to do on the security aspects. Yes, that's why not touch that subject, because it's really another big subject for that. Yeah. Yes, please.
Hi. You mentioned an increase in using AI and ML on the smart city data. Can you characterize what kind of data sets are the initial target for this? Is it primarily image data that you're looking at using these tools for, or is it generically all data that the cities are providing?
Yeah, so one of the, this AI and machine learning can go into all the action clusters, what I mentioned. But immediate thing, what I have seen is this, the energy efficient tools, for example, the energy efficient, for example, the grid, So they want to know that each consumers, how much energy they are consuming on every day, So that data, based on that data, they can come out with a graph. Okay, fine. Now each consumer is spending this much of energy. Machine can decide it. Okay, you are exceeding, you are above this. That's one thing. And transportation also, to a certain extent, you can also take that data and know the flow of the people, which direction they are going in, what time they are going it. You can control and you can plan. You see some of the cities, you might have seen that one bus goes there, no passenger at all, right? You can always plan on the intervals of the buses there, or local transit. Hope that answers your question. Yeah. Thank you.
Do you see any LoRa Sigfox investment as of today by the cities, or?
Yeah, as of today, I see only the prototypes, because there is a lot of that ISM band, still we have to go through that regulation process. There is still a question mark. We are getting there. In Europe, already implemented, because the already regulation has been passed at ISM band. So here, hopefully we should have, it's going in a very very paced manner. So we should see those aspects probably in 1 year or 2 years. As of now, I've not seen a real implementation, as everything is in the prototypes. Yeah.
Thank you. This seems to be a kind of a first world sort of bias or developed country bias here. I'm wondering what your view is on adopting smart city technology to emerging markets where there's less infrastructure, and perhaps even the concept of smart villages and things like that. Do you see any trend or movement in that direction?
Yes, my experience on that is that emerging countries, or the small villages, or the smart villages, what they call, I think those are the best example happening there. I would say, currently, all this enterprise, even the NIST for that matter, they want to focus on the, where the lot of applications, a lot of things on the urban cities. But doing that is another one, because they're saying that, okay, we are building it from the scratch, Small villages, they take it from the small villages. I was working with one of the village in the Nigeria. So it's a private university. So they say that we are no way connected to the government. We are no way connected to any agencies. We have got everything, even grid, they're having their own power, they're having their own public work department, they have their own government. Its funding is coming from some outside agency. So they said that let's build a smart campus, So that's whole university or the village is becoming a smart campus. That's actually quite easier to solve the problem, because at least we know what is not there. We are building it from scratch, It's like I say that, building a house from making it scratch or renovating it, So if you do that, that's, I think it is happening, but it will take some amount of time to get into this stage, what in urban cities is happening. Yeah.
I think that was it. So one last round of applause for Shiva.